this tutorial, I'm going to show you how to write a string replace Java application. This simple application processes a directory tree recursively and finds files with a given extension. For each file that has an appropriate extension, processing is done. We find strings and replace them with other strings. The string replace definition is held in a separate file and is loaded in the beginning of the program. Here's our program. I use this program to quickly replace styles in an HTML file while writing frontend. Here's an example usage. It's a sample HTML file with some styles. This page is simple, with a black background and 2 signs. Let's start my application. It has executed immediately. Take a look at the page that has been processed. The background is yellow now, and 2 signs are green. Look, the page code has been changed. Okay, so that was sample usage of my program. Now I will show you how it is coded. In this episode, you will learn how to read program arguments in Java, read and write files in Java, copy file bytes from one to another in Java, process a directory tree recursively in Java, and use map interface in Java. Okay, let's begin. How to read program arguments. Program arguments are stored in an args array containing strings. This array is accessible from the main method of the program. In my code, I check if there is an appropriate number of arguments passed to program. If there are not exactly 3 arguments passed, some usage information is printed. In the first argument, I pass a path to the file which stores information about how values should be changed. The second argument is a directory where the program will start processing the directory tree recursively down. In the third argument, a file extension is passed. Our program only processes files with a given extension. Now, look how I pass arguments to the program. In the Run configuration for the program, in the Eclipse navigate to Arguments tab. Here is the Program Arguments section. I pass arguments to the program, and each argument is separated by a space sign. Here's our sample replace definition file. Here's a directory where the program will start processing files and directories. And the last argument is HTML, the file extension that we want to process. So, we know how to pass and read program parameters in Java. Great! And now I'm going to show you how to do something much more complicated. Now we are going to read and write text files. This is a process file method of our program. Here, all the place logic takes place. Have a look. This method takes a file as an argument. This file is going to be scanned and changed. A file input stream is opened to this file. Next, a data input stream is opened for the file input stream that we have just created. To read data from file, line by line, a buffered reader is required. We create one by providing a new input stream reader with the data input stream as an argument while calling constructor. Okay, now one can read file line by line, and look at this while condition. We can call a readLine method of the buffered reader object which returns a whole line in the input file. If this method returns null, it means that the end of the file has been reached. Okay, here we create a temporary file in which processed file results will be stored. Next, a file writer object is created, which is used to create a buffered writer object. Now we can write whole strings to the output file. Okay, so we read the input file line by line. Here you can see some processing which will be covered later. For now, the important thing is this processing result is stored in the line variable, which is being written to the output file. An important thing while reading and writing files is to close all the use stream and writer objects in the exact opposite order that they were created. Okay, using streams and readers and writers isn't that hard. Now I'm going to show you how to copy bytes from one file to another. This is a very simple code. Take a look. I have this copy file method which takes source and destination arguments. At the beginning of the method I create an input stream for reading, an output stream for writing bytes. Next, I need a byte array with a fixed length, in my case, round number of 1024. There is an integer value which will store the current number of the bytes that have been read from the source file. Okay, now I have this while loop in which I read bytes from the input stream to the byte array by calling read method of the input stream. This method returns a number of bytes that has been read. This method returns a number of bytes that have been read. As long as the number is more than 0, it means that the end of the input file has not been reached. Here I write bytes stored in the byte array. I write bytes stored from the index 0 to index len. At the end of all this, the stream needs to be closed. Simple? Thought so. Now, our next code fragment processes directory tree recursively down. Watch how. Here I have my process directory method. This method takes a file descriptor as an argument. At the beginning, I iterate through the files that are stored in the directory that I call nodes. If a given node is a file, I call my process file method that I showed earlier. On the other hand, if a given node is a directory, I call this process directory method to the process in the same way. The last topic of this episode is about using map interface. I use a static map object to store information on how to replace strings. Look at the code. I have a static map object. This map stores a string object as a key and as a value. I create this object here. Since map is only an interface, I need to use a particular class. In this case, I use the hash map class which stores data with no order. Okay, now I create input streams and a buffered reader to my replace definition file, the same way as before. I read this file line by line. Each line is being split by calling strings split method. I know that my line will split into two strings, so I put the first one as a key and the second one as a value. Take a look at the definition file. The first value in the line is the key. Then there is a separator. And the second part of the line is a value. Now I'll show you how to use my map in this program. Here's our magic fragment where we find and replace strings according to the definition file. We iterate through the map keys. These are our keys. Each line is being checked for presence of the key. I use the strings index of method for that. If a string is present in a string that is being checked, this method returns its index. Otherwise, it returns -1. If we find a key in the processed line, a replace all method is called replacing all occurrences of the key with the value taken for that key from the definition map. We get the value for the key by calling a get method of the map interface. I hope this video was useful for you. In case of any questions, don't hesitate and write to us or leave a comment under this video on ITCuties.com. Have a nice day. See you later. Bye.